Morning. Sorry, good afternoon. Is my voice is audible to all?
Yes, sir.
Yes, sir. No.
Yes, sir.
So everyone, please switch on your videos. I will call you one by one. Rule number 31, 401, 402, 405. So please switch on your videos. Yeah, Sai Rohit. Switch on your videos, everyone. So these are directions from head of the department. So once you are switch on the videos, then only class will run. So please switch on your videos. Switch on your videos. Pujita, Chandana, dark room lo undodu nanu. Switch on your videos. కంపల్సరీ వీడియోస్ ఆన్ చేయాలి. కంఫర్టబుల్గా నేను ముందే చెప్పాను. నేను క్లాస్ స్టార్ట్ అవుతుందంటే కాలేజీకి వచ్చినట్టు రెడీ కావాలి, క్లాస్ అయిపోయే వరకు ఉండాలి. అంతేగాని ఇష్టం వచ్చినట్టు ఆన్ చేసుకొని మీ పనులు మీరు చేసుకుంటే యూజ్లెస్. సో ప్లీజ్ స్విచ్ ఆన్ యువర్ వీడియోస్. Yeah. Yeah. What is sport? Now I am moving towards third unit. If any doubts are there in the second unit, we will discuss later. So in our third unit, the important thing is here, I think, two-port networks. Two-port networks. What is port?
Changing.
What is port?
Changing, sir.
What is port? Do you heard about port? Where are the ports? Ports ఎక్కడెక్కడ ఉన్నాయో చెప్పగలరా? హరినాథ్. What is port? Or you can give the response to chat box also. What is port? Yes, one of the yes, Lokesh has given where ships are kept. Yes, correct. Okay na? Port. Inka next. End point. One of the friend has given end point. Next. ఇంకెక్కడ ఉంటాయి పోర్ట్స్? కమ్యూనికేషన్ ఎండ్ పాయింట్ ఇంకొకరు ఇచ్చారు. ఇంకా So out of the subject, please give the meaning of port. Where ports are available. సో మన సబ్జెక్ట్కి రిలేటెడ్ కాకుండా పోర్ట్స్ అనేవి ఇప్పుడు ఇంతకుముందు ఒక ఫ్రెండ్ చెప్పిండు, షిప్ని చేంజింగ్ పోర్ట్, వైజాగ్ పోర్ట్. ఓకే రైట్. ఇంకా వైజాగ్ హైదరాబాద్లో ఉన్న శంషాబాద్ పోర్ట్ కనిపించదు. ఎయిర్పోర్ట్ కనిపించట్లే మీకు హైదరాబాద్లో శంషాబాద్ ఎయిర్పోర్ట్లో.
Yes, sir.
సో హియర్ పోర్ట్ ఈస్ ద, ఏమైతే ఇక్కడ ఎయిర్పోర్ట్లో ఏమొస్తే ఫ్లైట్స్ ల్యాండ్ అయితే, ఫ్లైట్స్ ఏమైతే ల్యాండ్ అయితే, ఇక్కడ ఉన్న ఫ్లైట్ ఏమైతే హలో
Yes, sir.
షిప్ ఉన్నది వైజాగ్ పోర్ట్ ఉన్నది. పోర్ట్ దగ్గర ఏమొస్తుంది, గూడ్స్ తీసుకొని వచ్చింది, గూడ్స్ అక్కడ అన్లోడ్ చేస్తారు, మళ్ళీ లోడ్ చేసిన తర్వాత మళ్ళీ వెళ్ళిపోతుంది. సో ఈజ్ మై వాయిస్ ఈజ్ ఆడిబుల్ టు ఆల్?
Yes, sir.
Yes. So Vizag seaport is there, Shamshabad airport is there. These are same meaning. Clear? So ఇక్కడ ఏంటంటే ఒక పోర్ట్, ఒక షిప్లో ఏం చేస్తారు, మెటీరియల్ తీసుకొస్తారు, ఎక్కడి నుంచి వస్తుంది, అన్లోడ్ అవుతుంది, మళ్ళీ లోడ్ చేస్తారు, మళ్ళీ వెళ్ళిపోతుంది. అవునా కదా? సో హియర్ ఆల్సో సేమ్ థింగ్. ఫ్లైట్ వచ్చింది, ప్యాసింజర్స్ శంషాబాద్ ఎయిర్పోర్ట్లో దిగుతారు, మళ్ళీ శంషాబాద్ లోడ్ చేస్తుంది, మళ్ళీ ఎక్కడికి వెళ్ళిపోతే ఎక్కడికి సమ్వేర్. అంటే సి వాట్ ఈస్ మై కంక్లూజన్ హియర్? హియర్ పోర్ట్, వాట్ ఈస్ పోర్ట్ హియర్? Yeah, here a pair of terminals through which a current may enter or leave a network is known as port. Clear? A pair of terminals through which a current, అంటే ఇక్కడ కరెంట్ ఏంటంటే, అదే మన వైజాగ్ పోర్ట్ తీసుకుంటే, అంటే సీ పోర్ట్ తీసుకుంటే గూడ్స్, ఇక్కడ శంషాబాద్ ఎయిర్పోర్ట్ తీసుకుంటే ప్యాసింజర్స్. అఫ్ కోర్స్ గూడ్స్ కూడా ఉంటాయి, చెప్తాను ఇక్కడ. అంటే ఇక్కడ ఏంటంటే, సో ఇన్ అవర్ సబ్జెక్ట్ a pair of terminals through which a current may enter or leave a network. A current may enter or leave a network is known as port. A current may enter or leave a network is known as a port. Clear? That is a port. Two terminal device or elements such as resistors, capacitors, inductors results in one port. Two terminal devices are elements. Two terminal devices are elements. So resistor has two ends, current entering end and current leaving end. Similarly, capacitor is also two ends. So that's why these are the two terminal device. Can you please tell what is the BJT terminals? What are the BJT terminals?
Emitter and collector.
BJT is having how many terminals? Bipolar
Three,
junction
sir.
transistor, how many terminals? Three terminals. Clear? So for analyzing the transistor, which parameters we're using?
Collector.
Which
base.
network parameters we're using? For analyzing the bipolar junction transistor, which parameters we're using? You already studied in our EDC or EC. ఏ parameters యూజ్ చేస్తాం మనం? రెస్పాండ్ ఎవ్రీవన్. or else can give the or answer through chat box. ఏ పారామీటర్స్ యూజ్ చేసాం ట్రాన్సిస్టర్ అనలైజ్ చేయడానికి? ఐఎమ్ ఎక్స్పెక్టింగ్ ఆన్సర్. ఏ పారామీటర్స్ యూజ్ చేసాం మనం? For analyzing transistors, we are using H parameters. H parameters. H parameters means what? Hybrid parameters. One of the friend has given Z parameters. Z parameters, the name itself, Z is impedance. Impedance parameters. H parameters means here hybrid parameters. So how many are there in waiting room?
సార్ వెయిటింగ్ రూమ్ లో ఉన్నారంట సార్.
ఓకే ఓకే, I will allow. ఇక్కడ ఉన్నాక వెయిటింగ్ రూమే కనపడట్లేదు. ఉన్నాయి కదా డౌట్ వచ్చి ఫస్ట్ 12 క్వశ్చన్స్ yeah, hope everyone is joined, right? The terminal, yeah, this is the, oh yeah, manka waiting room uన్నారు 6 members. Submit all. So friends are continuously joining. It's a bad manner. You have to join the class within 5 minutes. Yes. Yeah, two-terminal device. Yeah, what are the examples of the two-terminal device here? Resistors, inductors, capacitors. So because of these two terminals devices or elements, the resultant network is a one-port network. The resultant network is the one-port network. So what is the three-terminal device here? The three-terminal device is the BJT, bipolar junction transistors. Because of bipolar junction transistor, the resultant network is the two-port network. The resultant network is the two-port network. We will see one by one. So most of these circuits we have deal with so far are two-terminal or one-terminal, two-terminal or one-port circuits. Clear? So a two-port network is an electrical network. A two-port network is an electrical network with two separate a two-port network is an electrical network with two separate ports. With two separate ports for input and output port. For input and output port. It has two terminal pairs. It has two terminal. It has TWO2 terminal pairs acting as access points. Acting as access points. The current entering in one terminal of pair leaves the other terminal in the pair. Clear? So current is entered in port 1. Current may leave from the port 2. From the port 2. Clear? So these are the examples. This is a simple black box. This is a simple, yeah, I will spotlight. So this is the simple black box. This is a simple block box. So that is a linear network. What are the linear elements? Resistor is one linear element. Inductor is one linear element. Capacitor is also linear element. Clear? So here initially I told the two terminal element or device is the resistor, inductor or capacitor. So this is the thing. This black box indicates the involves a resistor or inductor capacitor. It's having only one port. It's having only one port. So this is the port 1. Clear? So this is a current I. Can always current is that means directed by the arrow. Clear? This arrow representation I. Voltage is measured between the two terminals. Between the two terminals. So plus minus. This is the arrow will indicate current direction. Plus minus. This is the one port network. One port network. అంటే ఇక్కడ ఏంటంటే కరెంట్ అనేది ఎక్స్టర్నల్ నుంచి ఎలిమెంట్ కనెక్ట్ కావచ్చు, ఇంటర్నల్ నుంచి ఎక్స్టర్నల్గా కూడా ఫ్లో కావచ్చు. క్లియర్? సో దిస్ ఇస్ ద కనెక్షన్ బిట్వీన్ ఎక్స్టర్నల్ టు ఇంటర్నల్. అగైన్ ఇట్స్ ఇంటర్నల్ టు ఎక్స్టర్నల్. ఇట్స్ అ వన్ పోర్ట్ నెట్వర్క్. సో నెక్స్ట్ ఈస్ ద టూ పోర్ట్ నెట్వర్క్. టూ పోర్ట్ నెట్వర్క్ ఈజ్ హ్యావింగ్ దిస్ పోర్ట్ అనేది ఏముంది ఇక్కడ? పోర్ట్ చూడండి ఇక్కడ. నేను ఇంతకుముందు చెప్పాను షిప్ లో గూడ్స్ ఉంటే గూడ్స్ ఏమైతే బయట నుంచి వచ్చితే ఏమైతే ఇక్కడ అన్లోడ్ అయితే మళ్ళీ ఇక్కడ లోడ్ అయ్యి ఎక్కడైతే సమ్వేర్ ఇట్ మే బి అన్లోడ్. సో ఎక్స్టర్నల్ టు ఇంటర్నల్, ఇంటర్నల్ టు external, external to internal, and again it's internal to external. So this is a one port network. Clear? So this is a one port network. Similarly, this is a two port network. Two port network. Plus minus, plus minus. So this is a V1, this is a V2. V1, V2. V1, V2. So the current is flowing, direction is I1 here. So this is the leaving here I1. Current entering like this, leaving from like this. So I1. So here voltage is V1. Here voltage is V1. Similarly, here the current is I2. The current is I2. Entering from external to internal, leaving from internal to external. So this is a external to internal connection, internal to external connection. This is nothing but what? Port. This is nothing but what? Port. సో శంషాబాద్ ఎయిర్పోర్ట్లో తీసుకుంటే మనం ఏమవుతుంది? ప్యాసింజర్స్ వస్తారు, ఓకే, ఇక్కడ ఫ్లైట్ ల్యాండ్ అవుతుంది, ప్యాసింజర్ దిగుతారు, వెళ్ళిపోతారు. మళ్ళీ ఏం చేస్తారు? ప్యాసింజర్స్ ఇంకో ఫ్లైట్లోకి ఎక్కుతారు, మళ్ళీ వెళ్ళిపోతారు. సో దిస్ ఈస్ ద పోర్ట్. ఓకేనా? అందుకని చెప్పేసి నేమ్ మనకి టూ పోర్ట్ నెట్వర్క్స్ లో నేమ్ వచ్చింది, అందుకని రీజన్. దట్ ఈస్ ద రీజన్ బిహైండ్ దట్. సో దిస్ ఈస్ ద టూ పోర్ట్ నెట్వర్క్. సో నెక్స్ట్ ఈస్ So the two reason why to study the two port network. Such networks are useful in communication, control system, power system, and electronic circuits, electronics. Clear? So in our already studied your EDC or ECA, for analyzing electronic circuit, we are using H parameters. What purpose? Analyzing. Analysis means what? Determination of the resistance, determination of the resistance, clear, admittance, voltage, currents. These are the parameters. So by using these parameters, we can find out, we can analyze the electronic circuits. Communication also in the mun cheppar meer communication lo kuda chepparu. So transmission of the information from one port to the one point to the another point. In between, so many electrical and electronic circuit is there, but transmission purpose, analyzing purpose, we are using this kind of network. So if you want to transfer the power from one place to the another place, clear? Clear. Where we are for analyzing this power analysis also we are using the two port parameters. Clear? So for example, in Srisailam there is a power generation. In Kottagodam there is a thermal power station is there. Clear? In Godavari Kani somewhere is there a power generation generations are there. Okay, power generation is not a sufficient one. So we need to transfer that power from one place to the another place. How do you transfer this power from one place to the another place? Using transmission lines. What is transmission line? Transmission line is a composed of the resistors, inductors, and capacitors. Clear? So ఇవన్నీ కూడా analysis purpose we are using these kind of two port networks. Clear? So knowing the parameters of a two port network enable us to treat as a black box. Knowing the parameter of a two port network enable us to treat as a simple black box when embedded with a larger network. Clear? So for all entire one port network, two variables. One port network, two, of course all are voltage and currents only. One port network is having one current and one voltage. In case of two port network, four variables are there. Four variables are there. So input port, output port, input port, output port. So input port is having input current I1, input voltage V1. Output port consists of the output current I2 and output voltage V2. So the various terms that relate these voltage and currents are called parameters. Various terms that are relate these voltage and currents are called parameters. Clear? So next, initial I told the parameters are the Z parameters, Y parameters, H parameters, ABCD parameters, and T parameters also. Now I am moving towards Z parameters. What is Z here? Z is nothing but what? Impedance. Z is nothing but what? Impedance. Z parameter also called as a simple impedance parameter. What is the unit of impedance? Friends,
Ohms,
please
sir.
respond. What is the unit of impedance?
Ohms, sir.
sir.
Ohms. Very good. So this is the ohm symbol. So Z parameters, another name is the impedance parameters. Impedance parameters is commonly used in the synthesis of the filters and also useful in the design of the analysis of. So here I am using the word called synthesis. What is synthesis? What is synthesis? What is synthesis? What is synthesis? Cheppali. What is analysis? The terms are very, very important here. What is analysis? What is synthesis? So this is the two port network. So this is a simple initial I told this is a simple black box. So it may be anything, we don't know. This is a simple black box. Yeah, so this current is here I1. This voltage is always measured between 2 points. So V1. So this current is here I2. This voltage is here V2. I1 V1, I2 V2. I1 V1, I2 V2. So now tell me here I want to differentiate what is the difference between analysis and synthesis. What is analysis? Tell me. What is analysis? Analysis means input is known to us, the circuit is also known. What is the output? That is the analysis. ఏం చెప్తాను నేను? ఇన్పుట్ మనకు తెలుసు, this black box may be the circuit. Clear? So circuit. సో ఇక్కడ ఇన్పుట్ తెలుసు మనకి, ఇక్కడ సర్క్యూట్ తెలుసు. వాట్ ఈస్ ద అవుట్పుట్? దట్ ఈస్ ద అనాలిసిస్. ఈ అనాలిసిస్ మీరు ఆల్రెడీ ఈడిసిసిలో చేస్తున్నారు. అనాలిసిస్ మీన్స్ వాట్? డిటర్మినేషన్ ఆఫ్ ది voltage, determination of the current, determination of the voltage gain, current gain, and impedance, admittance. Clear? What is synthesis? Synthesis means what? Input is known to us, output is also known. What is the output? That is called synthesis. So input is, so this is the, synthesis means what? Input మనకు తెలుసు, అవుట్పుట్ కూడా తెలుసు, సర్క్యూట్ ఫైండ్ అవుట్ చేసేది ఏంటది? సింథసిస్. ఇంతకుముందు మీకు చెప్పాను, దీస్ ఆర్ ది ఇన్పుట్ తెలిసింది, అవుట్పుట్ తెలిసింది. we can find the circuit. So that is called synthesis. Clear? Simply speaking, one professor told that analysis means hello. Analysis means one professor told that before marriage analysis, after marriage synthesis. Before marriage analysis, after marriage synthesis. So this is the difference between analysis and synthesis. This kind of difference is very important. So next, moving towards so ఇక్కడ ఏం చెప్పాను నేను ఇంతకుముందు? ఏం చెప్పాను? దీస్ ఆర్ ది యూస్ఫుల్ ఇన్ ద డిజైన్ అండ్ అనాలిసిస్ ఆఫ్ ది ఇంపిడెన్స్ మ్యాచింగ్ నెట్వర్క్స్. Used in the synthesis of filters. Means that finding the filter networks. Input is, he will give you, output is also given to you. He asked to design the filter circuit. He asked to find the circuit. Are we find? Yes, we can find. That is nothing but synthesis. Analysis means what? He will give you input parameters, he will give you circuit, he will ask you to find out what is output. That is called analysis. So these are the analysis and impedance matching networks and power distribution networks. So the what is the power theorem? There is one theorem, maximum power transfer is theorem is there. What is the maximum power transfer theorem? Santosh, Lokesh, what is the maximum power transfer theorem? Whenever load impedance is equal to source impedance, the maximum power is transferred to the load. What is that maximum here? Only 50% of the power is the maximum. For example, if you want to transfer 1 watt, whenever ZL is equal to ZS, load impedance is equal to source impedance. So 2 watts into 1 watts, 50% of the maximum power is transferred to the load. That is the maximum power transfer. ఇక్కడ ఇంపెడెన్స్ మ్యాచింగ్ అనేది యూజ్ చేస్తారు అన్నమాట. క్లియర్? అనాలిసిస్ ఆఫ్ ఇంపెడెన్స్ మ్యాచింగ్ నెట్వర్క్స్ అండ్ పవర్ డిస్ట్రిబ్యూషన్ నెట్వర్క్స్. సో బై యూజింగ్ దీస్ ఇంపెడెన్స్ పారామీటర్స్ we can analyze the impedance matching networks and power distribution networks. The two-port networks may be voltage driven or current driven. Hello, voltage driven or current driven. These two-port networks may be. So this is the linear networks. So linear elements, resistor is a linear element. Here this is the input side of this linear network. This is the output side. Okay, now this is output input. So here there is a DC voltage source V1. This is I1, I2, V2. So two-port network driven by current sources. So here two-port networks are driven by voltage sources. First case, this two-port network is driven by current sources. So this two-port network can be driven by either voltage or current. Either voltage or current. Next slide. I am going to next slide. Yeah. Yeah, this is the black box. This is a simple black box. Yeah, black box is represented with the Z parameter as shown below. So this is a Z11. Z1, first one is the port Z11, Z11, Z12, Z21, Z22. Z11, Z12. That means what? 11 means what? Port 1 to port 1 only. What is 1 to port 1 to port 2 connection? What is Z21? Port 2 to 1 connection. What is Z22? Port 2 to. So the terminal voltage can be related to the terminal currents. The terminal voltage can be related to the terminal currents as clear. Here four parameters are there, four variables are there. What are the four variables are? Input current I1, input voltage V1, output current I2, output voltage V2. So among these four variables, two are dependent, two are independent. Two are dependent and two are independent. Yes. So in our Z parameters, the input voltage and output voltage are the dependent parameters or independent parameters. Hello. What are the dependent parameters? What are the independent parameters? Chapal. What are the dependent parameters? What are the independent parameters? So here there is a one equation is there. There is a relation between these two. What is according to Ohm's law? V directly proportional to I. V directly proportional to I. According to Ohm's law, V proportional to I. This proportionality is replaced by constant Z. Here I am assuming Z. Z is what here? Impedance. What is Z here? Z is equal to V by I. V by I. So to find out the impedance, what we are using here? Voltage and current. What is the relation here? Ratio. V to voltage to current. Voltage to current here. So therefore, here V1 and V2 are the dependent parameters. V1 and V2 are the dependent parameters. So this V1 is depends upon the I1. This V2 is depends upon the I1. So clear? So I1, I2 are the independent parameters. V1, V2 are the dependent parameters. V1 is equal to Z11 I1 plus Z12 I2. So V1 is equal to Z11 I1 plus Z12 I2. Z21 is V2 is equal to Z21 I1 plus Z22 I2. For example, if I want to find out the Z11, if I want to find out the Z1, what you have to do? We have to make. We have to make. We have to make. Here I want to find out the Z11. What I have to do from first equation? For first equation, please respond.
V1 minus Z12 I2 by I1.
చెప్పాలి ఏం చేయాలి? Z11 ఫైండ్ అవుట్ చేయాలంటే ఇక్కడ I2 ఏం చేయాలి? From equation 1 I want to find out the Z11. Simple mathematics. Z11. I want to find the Z11. What I have to do? I have to make second term as 0. Second term, this is the first term, this is the second term for this equation 1. You have to make second term as 0. How do you make second term 0? We cannot make Z12 or Z11 as 0. Only the option is the variables. What are the variables here? Either voltage or current. So we have to make I2 as 0. I2 as 0. Output current as 0. Clear? How do you make output current as 0? By opening the circuit. When current is 0, in open circuit current is 0. In short circuit voltage is 0. Open circuit current is 0. In open circuit current is 0. In short circuit voltage is 0. So therefore we have to open this output side circuit, then we can get the Z11. For example, if I want Z12, what I have to do? Z12 కావాలంటే సింపుల్ మ్యాథమెటిక్స్ లో ఏం చేయాలి?
I1 equals to 0, sir.
Yes,
open
I1.
circuit.
That means what? I1 is equal to 0 means what? We have to make input port as open circuit. Clear? So open circuit. Similarly here also. So this is the V2. ఇంతకుముందు చెప్పాను నేను V proportional to I. అందుకని చెప్పేసి ఈ రిలేషన్ మనకు వచ్చింది అనమాట. Clear? V proportional to I. Z parameters find out చేయాలంటే Z is equal to V by I. So Z11 I1 plus Z12 I2. The second equation is V2 is equal to Z21 I1 plus Z22 I2. So these are the two equations for Z parameters. Yeah, in matrix form we can write like this: V1, V2, Z11, Z12, Z21, Z22. So the Z parameters that we want to determine: Z11, Z12, Z21, Z22. So how do you find out? Like this. One time you have to make input port is open circuit, and second time you have to make output port is open circuit. So Z11 is equal to V1 by I1. From the T, I2 is equal to 0, where Z11 open circuit input impedance, Z12 open circuit transfer impedance. So this is the 1 means what? Both are related to input side. That's why we are saying open circuit input impedance. What about Z22? Both these suffixes are related to the output. Is the open circuit output impedance. So 1, 2, there is a transformation from port 1 to port 2. That's why it is the open circuit transfer impedance. From port 1 to port 2. What about Z21? There is a transformation from port 2 to 1. Z21. This is the open circuit transfer impedance. So this is the Z11, Z12, Z21, Z22. These are the Z parameters or open circuit parameters. Clear? So there is one example is there. We will see this example tomorrow. Next, Y parameters. So I think class will be in the gantla start chesina class
12:15, sir.
So please listen. Next, Y parameters. Y is nothing but what? Admittance. The reciprocal of impedance is nothing but admittance. What is the unit of admittance? What is the unit of admittance? So this is a Simon. Yes, clear. So representation is the opposite to symbol of this impedance. So this is also black box. So Y11, Y12. 1 only related to port 1, Y12 port 1 to port 2, Y21 port 2 to port 1, Y22 is related to completely port 2. Clear? So I1 V1, I2 V2. this black box that we want to replace with y parameters. Clear? This is having the y parameters. So this is completely admittance parameters only. Same thing here. So what is the ఇంతకుముందు నేను చెప్పా previously what are the your four variables are there? Among these four variables, two are dependent, two are independent. Now friends, tell me from this one, if I want to find out the y is equal to what? Z is equal to V by I. Admittance y is equal to I by V. Admittance y is equal to I by V. So ante ikkada I first vachedi next vachesi V. So therefore here I1 is equal to y11 V1 plus y12 V2. Clear? So here this y1 V1 is the input side voltage, V2 is the output port voltage. Input port voltage, output port voltage. Tell me what are the dependent parameters, what are the independent parameters here? The dependent parameters are the here low input current and output current are the dependent parameters. What are the independent variables? The independent variables are the V1 and V2. Always we can express dependent parameters in terms of independent parameters. Dependent parameters is equal to in terms of independent parameters. So that the independent parameters are the V1, V2, the dependent parameters are the I1, I2. So in matrix form, we may write like this. So I1, I2, Y11, Y12, Y21, Y22, V1, V2. Next. So how do you find out? Initially I told. So if I want to find out Y11, this is a simple mathematical equation. If I want to find out the Y11, what you have to do?
Output should be short circuited.
Very good, nice. V2 is equal to 0. The second term is 0. How do you get second term? Can we make y1 to 0? No, we cannot. But in our option is we have to make V2 is equal to 0. V2 is nothing but what? Port 2 voltage. So when voltage is 0, short circuit. If you're in a position to make output as short circuit, definitely this will give 0. Therefore, clear? So here y11 is equal to I1 by V1 and V2 is equal to 0. Y12 is equal to Y21 is equal to I2 by V1 and V2 is equal to 0. Clear? Here input port short circuited, here output port short circuited. Clear? Then we can find out this y11, y12, y21 and y22. This is the example. I will explain this problem tomorrow. So next H parameters. H parameters. What is the H stands for what?
Hybrid.
H stands for very good, hybrid. So in case of Y parameters, all parameters units are the mhos only. Clear? In case of Z parameters, the all parameters units are the ohms only. But in case of hybrid parameters, this is the combination of ohms and mhos. Clear? So in this, here also four parameters are there. Here also four parameters are I1, V1, I2, V2. Two are dependent, two are independent. Two are dependent parameters, two are independent parameters. Always we are expressing the dependent parameters in terms of independent parameters. Clear? So one is measured in terms of ohm one in mho and other two dimensionless. Since these parameters are mixed dimensions, so they are called hybrid parameters. These are mixed dimensions. It's a combination of two dimensions. That's why we are calling hybrid. Hybrid. Clear? So next, these are the things here. So it is a combination of this is a H11, H12, H21, H22. Tell me H11 is nothing but what? So ఇక్కడ నేను కంక్లూడ్ చేయాల్సింది ఏంటంటే input voltage and output currents are the dependent parameters. Input voltage and output currents are the dependent parameters. Input current and output voltage are the independent parameters. Independent parameters. So దీన్ని మీకు ఎట్లా ఎక్స్ప్లెయిన్ చేస్తానంటే, if I want to take tomorrow I will take example for transistor, then I will explain you. So how you are taking how input voltage is dependent, how output current is independent. I will take example. I will explain this concept using the bipolar junction transistor. So V1 H11 is nothing but what V1 by I1. V1 by I1 we have to make V2 is equal to 0. This is the impedance parameter. What is H12? H12 is nothing but what V1 by V2. V1 by V2. What is the voltage gain, Lokesh? Voltage gain is equal to ratio of ఎవరైనా ఒకళ్ళు చెప్పొచ్చు. ఎవరు చెప్పాలి వాళ్ళ పేరు చెప్తాను. అందరు కూడా వీడియో ఆఫ్ చేసి మంచిగా నిద్రపోతున్నారు నాయన. మొత్తం వీడియో ఆఫ్ చేసి నిద్రపోతున్నాను. దిలీప్ వర్మ మొత్తం వీడియో ఆన్ చేసి నిద్రపోతున్నారు. ఒక్కడు కూడా ఆన్ చేయట్లేదు వీడియో. జస్ట్ ఆన్ చేయమన్నప్పుడు ఆన్ చేస్తున్నారు, మళ్ళీ ఆన్ చేస్తున్నారు. లోకేష్, మిస్టర్ లోకేష్,
sir.
వాట్ ఈస్ H11?
Short circuit
Short
input
circuit
impedance.
input impedance, sir.
That is a ratio of input voltage to input current. No doubt it is impedance. Clear? Input impedance. That to input impedance. What is the voltage gain? Voltage gain is
H12.
ratio of output voltage to input voltage. But here we are getting H12 is equal to V1 by V2. So V1 is the input voltage, V2 is the output voltage. It's nothing but what? Ratio of input voltage to output voltage is what? Ratio of input voltage to output voltage. ఏమంటారు దీన్ని?
Open circuit reverse voltage.
Yeah, reverse voltage gain. Reverse voltage gain. Of course, why you are calling this reverse voltage gain? We have to make the first term as 0. So we cannot make H11 is equal to 0. We can make only I1 is equal to 0. That is in our hand. Clear? So the parameters are constants. We cannot change that parameters. Our variables are the only voltage and currents only. Clear? So H21 is the short circuit forward current gain. The current gain is always ratio of output current to input current. Next is the H22 is the open circuit output impedance. So thank you very much. Have a nice day. We will see tomorrow. Example problems of Z parameters, Y parameters, and discussion. Yeah, shall I end the class for all?
Yes, sir.
Right, thank you. Hello, Anjas.